Hey boss Deva, since you opened this video, you've granted the first seat where we are going to talk about this, which is LM35DZ, and it is a waterproof temperature sensor. To explore it, we need these 3 jumper wires, and then we have also this Arduino. Stick around and watch this video till to the end, because the end will justify the reason why we made this video. And as you see here, you see the LM35 temperature sensor is made by probe, and then that probe is connected to 3 cables, which are red, black, and yellow, and then red and black are for supplying, are for plus 5 volts and the ground power supply, then the yellow is for the data out. Then one reason behind this sensor worth using is that it doesn't need the library, and of course to use it is very easy because the output of it is 10 millivolts per increase of 1 degree Celsius. It means at increase of 1 degree Celsius, the output is 10 millivolts. So that will be easy to program this sensor. Let me try to solder these wires here, and I will be back after. Okay guys, now you see that I finished soldering the jumper wires on our sensor, and I covered them with heat shrink. You can check the video shared right there in the corner, then you can also learn how to use heat shrink tubes after joining the cables. Let's continue by connecting Arduino with the sensor itself. And as we said before, we knew that red is a plus VCC, and I will connect it to Arduino plus 5 volts just like this. And again, my black wire will go to ground, and I will be reading the analog in at A0. So the circuit is shared down in the description, and now let's go to the code and see how they work. Finished connecting the circuit. Let's jump right to the computer, and you see that I have my Arduino open. So let's try to explain a bit on the code. You see that we started declaring the variables, and then you see that you have the sensor pin, means analog pin 0 where our sensor is connected. Then you have the variable in which you will store the voltage, means we will first convert the readings, means the analog resolution into voltage, and then we will convert them into temperature and then save them into variable called temperature. And of course here we started the serial monitor, that baud rate, and then here you see that in a variable called the readings we are taking the analog resolution from the sensor, and then you convert them into voltage, because the analog resolution span between 1023 and 0, that is the maximum, and then we take 5, then divide by 1023, and then you find the voltage per resolution. That voltage obtained will be multiplied by 100. Remember, you have seen that the increase of 1 degree Celsius detected by a sensor results in 10 millivolts. So let's try to make like a simple mathematics here. So if we have like one increase of degree Celsius that results in 10 millivolts, it means 1 degree Celsius corresponds to 0.01 volts. So if 0.01 volts correspond to 1 degree Celsius, so 1 volts will be 1 over 0.01, which will give us that 1 degree Celsius increase on sensor readings will result in 1 times 100. That's the reason behind that math in the code, where we take the voltage reading and then multiply by 100. After all of that, we will print this word temperature, and then followed by the temperature readings, means the value stored in temperature, and then we put a delay of 100 for each print. So if I try to plug the Arduino and then upload the code to Arduino, you see that the codes are done uploading. And if I open serial monitor, and there you see that we are reading 24, and that is the temperature of the sensor that is floating in the air, not in the water. So if I put the sensor in the water, see that I put the sensor in the water, we will start reading the temperature of the water. First we were having 24, and as I dip the sensor in the water, you see that it is giving me the readings of water, which is now getting decreased to 23, then 24. So you can see that these readings are the readings obtained from that glass of water where the sensor is dipped in, and you can confirm that this sensor responds to the temperature of water. Guys, I hope that you enjoyed the video. Please give it by subscribing on this channel, hit a like, and then share this video to the one you think may need it. Ciao, bye, we love you.